The 50 kilogram circular piston shown in the figure floats on 0.12 moles of compressed air. How far does the piston move if the temperature is increased by 100 degrees Celsius? Okay, so we are asked to find how far up the piston moves. So this is going to tell us that, so that means that y is equal to delta h, which is going to be the total height that it moves up, minus h, which is how high it originally is, and we were already told by our professor that this h is going to be equal to 23 centimeters. Okay, so now that means that we have to find what this h is, and this part was tricky for me to figure out, but I had to kind of think about it like that we are told that the piston is circular, and so it's easier to visualize it looking at it like this rather than this. So if the piston is circular, that means that you could you can see that you could find the volume of the piston if you were to multiply the area of this part times the height. So that means that if we just wanted to find the height, that would be h is equal to the volume divided by the area. However, we don't have the volume or the area, but the area is easy to find because we know that the area of a circle is pi times radius squared, and then we also know the ideal gas law equation says that the pressure times the volume is equal to the number of moles times R, which is the universal gas constant, times the temperature. So we could solve for V using this equation. We were already given what the number of moles were, and we also know what the universal gas constant is. However, we weren't given pressure or what the total final temperature is. But the final temperature isn't very hard to find. We just say that the final temperature is going to be equal to 100 degrees Celsius, which is by how much it increases, plus the initial temperature, which was 30 degrees Celsius. So it's going to give us that the final temperature is 130 degrees Celsius. And then if we convert it to kelvins by adding 273, we're going to get that the temperature is 403. So we have the temperature. All we need to find is the pressure. We know that pressure of air is equal to the pressure of the atmosphere plus the pressure of the piston. We were already given what the atmospheric pressure is. We were told that it was 1 atmosphere, but we weren't given what the pressure of the piston is. But we know that that is going to be equal to the force divided by the area. So force is just going to be mass times gravity, and the area, because it's a circle, is going to be pi times radius squared. So now we can begin solving for what the pressure is. So like we said, the pressure is equal to the atmospheric pressure plus this, which is the area of the piston. So we're going to get that one atmosphere, the pressure is going to be 1 atmosphere plus 50 kilograms times 9.8 meters per second divided by pi times 0.05 meters squared. And this is the diameter divided by 2 when converted to meters. And so we're going to get that the pressure is equal to 1.62 times 10 to the 5th Newton meters if you convert atmospheres to Newton meters. And so now we can solve for the volume. We already know that volume is equal to moles times the moles times R times the temperature divided by the pressure, and we were already given that is going to be 0.12 moles times R, which is 8.314 joules divided by moles times Kelvin, and then we're going to multiply that by the temperature, which we said was 403 kelvins, and then we can divide that by the pressure that we found here. So the volume is going to be equal to 2.48 times 10 to the negative 3 meters cubed. So now that we have that, we can get the final height. So we said that the height was going to be equal to the volume divided by the area. We have the volume, we said that area was pi times radius squared, so the height is going to be 2.48 times 10 to the negative 3 meters divided by pi times 0.05 meters squared, which is going to give us that the final total height is 0.32 meters. So now we can find how much the piston moves after the temperature is increased by 100 degrees Celsius. So we're going to get that y is equal to 0.32 times 0.23, which is 23 centimeters converted to meters. And so we're going to get that is 0.09 meters, which is equal to 9 centimeters.